Hi, everyone. Last time we talked about the standard normal distribution, which is indicated by this bell-shaped probability density curve. The standard normal distribution is a special kind of normal distribution with mean 0 and standard deviation 1. But what about normal distributions in general, with a general mean mu, which could be 0 or something else, and standard deviation sigma, which could be 1 or something else, positive. We're now going to talk about normal distributions in general. What if a normal isn't, for example, the standard normal distribution? All right, well, here's the key thing. We're going to be doing conversions where we're basically changing from this picture, from the general normal, over to this picture with the standard normal. So we're going to get things down to z-scores. We've done this before. Part A, standardizing normal scores. That means finding z-scores to find probabilities. Assume that X has a normal distribution with mean mu and standard deviation sigma. Here's the shorthand. X has as its distribution a normal distribution with mean mu and standard dev sigma. Now, in general, mu and sigma, the mean and the standard dev, could have any units: points, inches, feet, pounds, light years, and so on. But do make sure that mu and sigma are written using the same units. So for example, mu should not be in feet while sigma is in light years. That should not happen. On the homework, I will not trick you like that. Now, we're assuming that X has a general normal distribution. When I write down Z, I'm going to assume that Z has a standard normal distribution, meaning that Z has, as its distribution, a normal distribution with mean 0 and standard dev 1, the standard normal. Z-scores have no units, so these are not going to be in feet or light years or whatever. They have no units. So again, the idea is that we're going to be changing from the normal distribution in general to the standard normal distribution. We're going to engage in a standardizing conversion process. To find probabilities for values of X, which have the general normal distribution, we need to transform or convert from X scores to Z scores. We're going from a general normal distribution to a standard normal distribution. And we're going to use our usual formula for Z scores. Remember how we calculate Z scores. You take the original X score, subtract off the mean, and then divide by the standard deviation. If we have population data, we'd have this format: X minus mu all over sigma. And we usually round off to 2 decimal places. Again, in this process, when we subtract off the mean from all the data points, then we end up with a new data set with a mean of 0. When we divide by the standard deviation, we end up with a new data set with a standard deviation of 1. That's what we did early on in the semester. We're now going from data sets to distributions in general. In this case, we're talking about normal distributions. And we're standardizing from a general normal distribution, where these guys come from, to a standard normal distribution, where these Z guys come from. So again, we're going to use that formula to convert from these various normal distributions, which could have various means and standard deviations, to the standard normal distribution, the standard normal distribution. There's only one of these guys: the normal distribution with mean 0 and standard deviation 1. Z-scores higher than 0 indicate that you're above the mean, which was the case beforehand. A Z-score below 0 means that you have a score that's below the mean, which was the case beforehand with the general normal. We're going to talk about specific examples next time.